always good to kind of put together your thoughts of where you think you're headed. You might think you know it, but it's not till you write it down, that you realize, okay, this is why I'm doing this, and what drives me. I actually had the opportunity to do that, a statement of purpose when I was applying to schools. And that was a good exercise. I mean, it's always, that's one of those things that kind of sucks about, applying to things. It's the actual application, filling your name and all that stuff is boring. But, writing something that, kind of captures the essence of who you are, that actually is something you can use to kind of reflect. And you can do it when you're doing a cover letter for a job, or when you're doing a statement of purpose for school, or, you don't need to have a reason for it. You can just do it. So before I'll just dive right in. I'm a data scientist with an extensive background in entrepreneurship and data-driven web and app development. What led me to data science was an interest in decision making, not only through algorithms, but also the human aspect, the cognitive science and behavioral economics. Hence, I'm passionate about providing the often missing link between data and decision making. And machine learning interpretation and causal inference helps bridge that gap most robustly. This is what led me to become the author of the best-selling book called Interpretable Machine Learning with Python. So that's the book Mo was referring to at the beginning of this session. So this has been my journey. It's a long journey. I don't know if I look the age that I am, but certainly it's been a long time. So in 1992, I was, starting high school, and that's when I got involved in databases. So I learned DBase and FoxPro for DOS, used them for projects in high school. Subsequently, I learned Microsoft Access 1.0, making webs. So I would make websites for fun, and I was therefore a pioneer in web development. It wasn't until 1999 that I had my first full-time role, and this is while I was, in college, and it was making sports betting websites, which are websites that are very data intensive. I learned SQL with Oracle, but following years I did with SQL Server, MySQL, Postgres, and others. And then in 2006, I was still working and I was in a similar field. I think by then I was in casinos, and data storage was not cheap. So my job involved a lot of ETL, which is extract, transform, and load operations, connecting data sources and analyzing data. In other words, business intelligence. But it wasn't quite called like that. I also used A/B tests to optimize websites. And then we fast forward to 2015. I'm involved in even bigger data, and for the first time in machine learning. That's when I founded a search engine startup. And so the first time I needed to learn ETL on even larger scale, NoSQL databases and machine learning methods. A little bit shortly after, in 2016, my startup got admitted in the Harvard Innovation Labs. So that was very good. I ran the startup for a few years, and when the startup ran out of money, that's when I decided to go to school. I went and got a master's in data science, learned computer vision, more big data tools, and got a better understanding of statistics. That's around the time I took interest in interpretable machine learning, kind of as a result of both my startup and also getting into school. In 2019, I started working. I and first then as an intern in a 3D printer manufacturing company, and then 2020 I got a job working in as a agronomic and climate data scientist. Also, I was recruited to write a book on the topic I'm very passionate about. That was 2020. So my vision is to help lead organizations at improving decision making by leveraging descriptive, predictive, and prescriptive analytics, but most importantly, enabling them with interpretation and optimization of outcomes, models, and processes involved. So what you see here to the right is something I did for my internship at Formlabs, the 3D printer manufacturer. So this is what is it called? Infographic of all the different KPIs and modeled on after all the amount of data that's coming in and out through a funnel, if you will. And so, all right. So my purpose is at the cross section of all of these things. It's something I love, something the world needs, something fortunately I paid for, and something I think I'm good at. So data science is right here. This is what, typically we call, well, in Japanese, it's called ikigai. Is that, something that provides sense of fulfillment. The constraints for those things is I want to feel like I'm doing something good for the world. I mean, for society, the environment, and so on. Something that I don't have to kill myself working so hard at that I won't feel well. And at the same time, gives me the liberty to do other things that I'm passionate about. So those are constraints I put on myself, because some people find themselves doing something they love, but it ends up consuming them, or, they love it, but, somehow they realize it has all these terrible side effects. So I keep those constraints in mind. Anyway, my advice for your journey, I have 3 sections for that. I think I didn't mention them at the beginning, but anyway, it's not that important. It's going through unicorn training, getting your foot in the door, and making your mark. So first of all, going through unicorn training. Basically, there's this idea that you need to know everything. If organizations think they want full stack, jack of all trade, perfect, have everything, generalist data science. And the answer to that is no. Data science is a vast body of knowledge. It's impossible to know it all. It will continue to evolve. So, even if you knew it all right now, you won't know all of it tomorrow. And so therefore you must focus on fundamentals. And don't forget the science. Data science is foremost a science. So you have to keep that in mind. And then you can explore everything else to figure out your niche. But be careful, this body of knowledge has monsters where you least expect it. So this is what I envision. It's like, if my previous field of web development was a lake, data science is a vast ocean that is completely yet to be explored. And in other areas, as you see here, filled with, with monsters and things that, areas that you don't, people don't venture to come into or beware. So there's a safer or more grounded side of the ocean, and it comes with the classics that are fundamentals to scientific inquiry, such as probability and statistics, hypothesis testing, experimentation, and a statistical learning. Also, there are other areas of math besides linear algebra and calculus that have seeped into data science methods, such as graph, game, and information theory, to name a few. And then there's another part of this ocean that also draws from computer science, such as data management, SQL, big data tools, data engineering, and so on. This is also a relatively safe area. Also, from a business organizational point of view, data was found useful for optimizing decision making, which spawned the fields of econometrics, operations research, and business intelligence or analytics. Um, so these are these areas in orange. You know, are classics, and they're definitely part of data. Well, at least of the canon that we call data science. These days, although it's the areas that we haven't mentioned, the parts in the middle that we most associate with data science, it's often more driven by an engineering than science. Hence, what I call the sea monsters, things you have to be careful of. You always have to keep the data in mind. You have to anchor things to ideas behind the data, their properties, all your decisions, be them, feature engineering decisions, be them hyperparameter tuning decisions, they have to be fundamented in something. You can't be arbitrary when you make these decisions. So that's why I always caution people to start their journey in these sites, so they become well versed in understanding data, and then understanding things that process those data on this side. So this is my, what I've adopted is my philosophy. There's a data fitting, and it's a quote by Julia Pearl. He wrote a book a couple of years ago called The Book of Why, which I highly recommend. The quote says, "The data fitting school is driven by the faith that the secret to rational decisions lies in data itself, if we only are sufficiently clever at data mining, in other words, machine learning. In contrast, the data interpreting school views data not as the sole object of inquiry, but as an auxiliary means of interpreting reality. And that reality stands for the processes that generate the data." In other words, you have to be always cautious with what is the data generating process. In other words, how was that data generated, and how is the data going to be used? How is it meant to be used? And that's something, even when you're doing things like modeling, you also have to wonder, what is the model going to be used for? Because it's not going to be used for the purpose you intended, then people are not going to, it might find, some strange ramifications, unexpected ramifications. So that's just a tip. Okay, the next thing is getting your foot in the door. So how you get an entry level, how to get to be entry level when the experience is always required. The first step would be to make your own experience. Create projects that have a business use case and design a prototype. It must be creative and well thought out. Think of projects that will impress or be useful to companies you want to work for, and do those. Like, for instance, there was a time in which I thought it'd be cool to work for automotive manufacturer. So I created this project, which was a yawn detector. So I could, if there was a camera in the dash facing the driver, it could alert the driver if the driver was sleepy, some kind of warning system. Systems like that already exist now. This was like done 4 years ago, but you guys could think of things that would be interesting to potential employers and do something like that. The next thing is cast a wide net. Competition is fierce, so don't apply only to 10 jobs. Apply to at least 20 a week till you start to get traction. That is going to vary also depending on the niche or the kind of area you want to apply to. Some are more competitive than others. Some have more jobs than others. So that's more or less a ballpark. I said about 20, but you could increase it or decrease it accordingly. Um, don't make the rookie mistake of sending the same resume for hundreds of different roles. Each job description is different, so it doesn't make sense to send the same resume. Right now, applicant tracking systems or ATSs filter and sort based on if they have the right key. The most sophisticated ones use machine learning to screen you, and you might notice that they'll reject you right away if they find nothing. If they find a 0% chance of you getting accepted by a human screener. So I suggest you make different versions of your resume and cover letter based on the job, and even tweak it a little bit for the job description. You can see here, these are just a handful of different resume versions I have. I have a resume version that is for computer vision, another one that's like a more general role, one that is for geographic information systems, one that is more for NLP, one is for a more time series kind of role. And so showcase your work in each of these that are kind of applied to that kind of job, showcase, experiences, projects, technologies that you work with that have to do with the job. I can't tell you how many times I've, even for the role I'm in, which is in, agriculture, I've had people apply for jobs in my company and the resume is NLP all the way. Had they cared to ask or looked at the job description, there would have been no NLP in the job description because that is not something we typically do. So it just comes to show that they just didn't, put too much attention to that. Or maybe they did, but, in the application itself, but didn't really realize that, instead of impressing us, it ends up, making us wonder, can they do something other than NLP? So to think strategically, I think it's important that you track the process and record every data point. Doesn't need to be a complicated thing. I would use a spreadsheet, put the name of the company, industry, role title, salary range, link to the job description, date applied, and what date it reached every other stage. I would also rank it based on my interest. This is important. So you can, at a glance, realize how much effort you should put into scheduling a coding test, or you should try to negotiate a better salary. Or in some cases, you might be applying to jobs that, you have a higher likelihood of getting, but your interest is really low. So those are good for practice. Those are good for, okay, I'm going to practice, my interview, how you call it, your interview skills. So as for making your mark, by that, I mean how to continue to advance your career in a direction that is best for you, and also unique to you. I think it's important you find your space where you express yourself in a way that is, like where when you apply for your next role and the next one afterwards, they look at your resume and they look at the work you've done and say, nobody else could have been best suited for this role, because nothing's worse than be, completely exchangeable in that sense, because these might be the best times to, there might be plenty of jobs out there, but we don't know about tomorrow. So, kind of having your own kind of trademark, having your own kind of brand, if you will, that is important. Well, the first thing you have to understand is you have to embrace what you don't know. It's a big field, so it's okay that you don't know every topic or method or algorithm. Admit it. You ask someone that does or Google it, and eventually you'll come to master it. And then the next thing is comfort zone forbidden. Be prepared to learn new things all the time and dive deep into them. Strengthen hard and soft skills equally. Data does not speak for itself, so you'll have to speak for it. Data problems are often not a one man job, so you'll have to be able to work well with others. Real world data can come with many surprises, so you'll have to be very adaptable and organized. And lastly, data science is a creative pursuit because data is very malleable. Therefore, you can play with it as well as with the process. You can use both sides of the brain when dealing with data. Don't always follow recipes. Don't make a habit of always copying and pasting things from previous projects. Try something new. Feel free to color outside of the lines. So that's my last tip. Sorry, it's kind of abrupt the way this ends, but thank you for listening to my session.
This was awesome, Serge. Thank you so much. Truly appreciate it. Just one a quick question for you. Most of our students are, changing roles in their field. What
Yeah.
is one piece of advice you would give to somebody who, let's say, has never been in IT, hasn't coded that much? How do they get comfortable with the whole data science world?
How do they get comfortable with data science world or just coding?
All of it, pretty much.
Okay. Well, it's just a question of practice. Um, they'll get comfortable once they've written the same code 100 times. You know, who knows? Maybe even 10 times. But it will take plenty of times to actually um, get to know it, get to not only know it and understand it, but be comfortable with it. Because there's some things, even for myself, I still Google. Like I still Google how is it you do this in Python? And I've been coding for, over 20 years. But there are other things that are are really good to know because you do them so often, they're good to know, like have it at the top of your head. And once you're able to know that kind of becomes a feedback loop of confidence. And I think that's very validating to someone that's starting out. But even for someone that's starting out with coding, um, don't feel like like you've lost the battle just because you don't remember some coding syntax or some coding concept. That's okay. We all have those moments in which we forget that.
Awesome. Thank you so much. Brother Mo, you're on mute.
Mhm. Mhm. Good. Good. Yeah. That's quite comprehensive. Yeah. It's just a lot of people, they just like dive in the deep end. They're from day one. It's all like deep learning, deep learning, deep learning, and they just forget about the probability statistics, and forget about the basic, the even the most fundamental Python. If it's not NumPy or tensors, they're not learning it. And there's many use cases to learn other things, SciPy and pandas, and even basic list comprehension is it's really important. So um,
Hi, Serg. Can
Hi,
I ask
Serg.
a question?
hi.
Okay. Thank you very much. Hi, Serg. Thank you very much for your, time and detail of your journey. I was going to ask you about how a week of a data scientist, look out in the real practice. How many projects they have in their hand for the month or the week or 2 weeks time. What are the key areas that a data science gets challenged with, meaning what kind of libraries or the packages are normally used in the life, and how much coding versus data decisions taking place in their weekly or bi-weekly time. So if you can elaborate the life of a
Mm,
data scientist on a job, would be very helpful.
mm. Well, my I don't think my job is typical. If I ask my colleagues in that sense, it really depends on what kind of industry you work. There are some that are faster paced than others. Like my work that I'm doing this year might not get shipped. I mean, it might not be in a production environment till 6 months till a year, uh, because of the nature of the agriculture, digital agronomy or digital agriculture industry. Um, Also, because of that same nature, the projects I do are, there's some few that are like just a proof of concept, and those might take 2 weeks, a month. But there are other projects that take a year, you know, others that take three or 6 months. You know, it really varies. the scope of a project, depending on what the kind of data is, how many people are involved, what's the urgency if I'm working on other things at the same time. I get a sense that people that are working in other industries like finance or one of the tech giants like social media, their workload is a lot quicker in that sense. These projects are less about they're most about the data's already ready. You don't have to clean clean the data, and they just have to do a lot of model building, and the model building part is a lot quicker. As far as like my day to day, yes, I do coding every day. Some days it might be 5 hours of coding. Some days it might be one. It there is some days are a lot of meetings and planning sessions and writing emails and things like that. And other days I don't have any meetings at all. So it really is shaped by meetings. And that's something that also varies from company to company. Some are like have less of that than others. Some adopt a more like meeting free approach than my own company. But we have reasons for having the amount of meetings we have. We have a lot of stakeholders. We have competing interests between different departments and so on. So it really depends. So I hope I answered all your questions.
You did. Thank you very much.
Yeah, I have a question. So you mentioned like you apply for like numerous jobs, like maybe 20 a week or something. So what would be the more efficient or efficient way or popular way to apply? Like, is it like look for websites like LinkedIn and keep applying, or go to their company website and keep applying, or could you give or could you shed some light what could be a more efficient way of doing that?
I do go to LinkedIn. LinkedIn is a good repository for that. You can also do that in Google. You can go to Indeed. But what you'll find is a lot of duplication. So you can have all three tabs open and just gather. That's the first step I do, is like gather jobs from there, jobs that I'm interested in from all of them. But then the next step is figure out if they're real, because that's a real problem. There's jobs that are there that they're expired. There are jobs out there that aren't real, that they're just trying to catch your information. That some company that wants to put you in their job database, put that job out there to fish potential candidates for whatever job portal they have. So I'd be careful with that. Because it's a waste of time. So how do you figure out they're real? You have to go to the career site of the actual company. So you go to the LinkedIn, you can click on the LinkedIn link, and if you see it open, something official from that company, then it was probably placed by a recruiter from that company. Otherwise, what you do is you go to the website of that company, you go to their career site, you search for that job, and then you find the real link. So the first step is gathering those jobs, grabbing their links, their real links on their websites to their job description. And another thing I did, and I didn't mention, and it is important, because once you've done this enough times, you realize which applications are quick, and you realize that the applications that go through systems like Greenhouse are like, you can do them in less than 10 minutes. Whereas the ones that are like from another system, like ICBM, I forget the name of that one. What's a very bad one? I forget, but there's some systems out there that, the application is guaranteed to take over 20 or 30 minutes. And the reason is, once you upload the resume, you have to enter all the stuff that's in your resume manually. So I'm not discouraging from applying to those sort of jobs, because there's only one way of doing it. You have to enter it. But I would prioritize the jobs that were quick over the ones that weren't, sometimes, if I didn't have enough time. So as one of the pieces of information I put in my spreadsheet, I put what is the system they use. So, like when I have a spare moment, I'll do that. I'll do those first. Because like what I would end up doing, and this is what I did when I applied to my job at Syngenta. I think that time I applied to 120 jobs in total. I ended up having interviews for like 5, and I actually got offers from 3. So that was good. Was it 5 or 7, something like that? So like it's not always, and I'm a career transitioner. It's not always easy. Like I had my classmates at my master's tell me, like, oh, you've already have experience with data. You must be very easy for you. In reality, I think the opposite happens. Like there is a threshold where they think already, you're either overqualified or you have no qualifications because you haven't had data science in your resume. So they think it's kind of a problem because you think, oh, it's not this person is, has this long career, storied career, but, doesn't have the experience we're looking for. So it becomes like a negative, unfortunately. So that's something that's unique to the career transitioner. And it really depends if your field is already connected in some way to data science, or at least overtly, because it might not seem obvious to someone that web development is connected to data, but it is. But there's some fields that in one way or another might have more of that than others. So you have to make that pop out in your resume.
Right.
Thank you.
I've got a question.
Yeah. Mm-hmm. Yeah.
All right.
Thanks.
Well, I've got a question, Serg. Serge, thank you for walking, through your journey. It's very inspiring. Could you talk a little bit about where do you see the field going in 5 to 10 years, and a bit about interpretable machine learning, like how it relates to how you put it, to solving a business decision?
Yeah. I think the field actually is as much as everybody is a lot of people are learning programming to become data scientists, and a lot of software engineers are transitioning into data science because it seems like easier to learn all the math and the statistics, and then the rest is covered. Reality, I think, is a lot of it is going to become no code and low code. I think it's going to be it's actually a lot harder to do data science, having to deal with all the programming. It's hard to manage, it's hard to coordinate, it's hard to collaborate. With all the tools that we have, which are wonderful, we have the GitHub and we have a lot of collaborative tools, but still coding is a burden. So a lot of tools are trying to take care of that burden for us, and I think that's a good thing. So I think that's like the biggest transformational change that's going to happen. A lot of things are going to abstract that. They're going to take care of a lot of that. The other thing is that, of course, more powerful models are going to come around, more tools that we can leverage to take care of that. A lot in the area of NLP, of computer vision, but also things that deal with tabular. And in that area in particular, I think, one of the most promising things that's out there is going to be in the field of interpretable machine learning, in particular with causal and counterfactual methods, something I'm very interested in. I'm kind of, looking at what's coming out of research in that area. To answer your question in regards to interpretable machine learning, the reason I see it as very promising is because, like, we're making decisions with models, right? Ultimately, like, even if the model was designed just to answer a question, many times that question is like either automated, automatically turned into some kind of decision, or a human is going to take that and probably take, the model's word for it and say, okay, the model has to be right because it's right, 95% of the time, or whatever that is. So it's important to be able to understand the why for that decision, because not only for the understanding of the end user, because that's nice, and because it might be required by law in many instances, but also because we also need it for ourselves, because that's how we improve models. Like, that's how we go the extra mile and cover that gap, not only in terms of predictive performance, but also in the understanding of the business or the system that created the data to begin with. So, like, there's a lot of cases in which we'll have like a discrepancy, we'll have something that doesn't quite make sense, and the model will realize that it might be right for the wrong reasons, and that might be very useful, because that will not only help us figure the model, but will help us improve whatever is in the system that is creating the data in such a way where it confuses the model. And this might seem very abstract, but like the example I can think of is, for instance, a famous example of a model that decides if between if a picture is of a dog or of a wolf, and they realized it was right a lot of the times, but the reason it was right was because the pictures of wolves had a lot of snow in them, right? So that's the reason it thought it was a wolf, right? So this wouldn't be useful in a production scenario, because, like, say you're trying to protect a herd of sheep automatically from wolves, and of course you have dogs that protect the sheep, so you're okay with dogs being near the sheep, but you're not okay with a wolf, right? That wouldn't be useful unless it was the winter, and even then they might confuse the model because, after all, like, dogs also hang around in the snow as well. So
all right, thank you so much.
I do have one last question for you, Serg. So, do you, while we're on the topic of jobs and job hunting, things like that, do you know of companies or resources that are willing to offer, startups or training facilities like us internships for our students, so they can get some sort of experience? I know there's Kaggle out there's GitHub, all kinds of stuff, but sometimes when you go on there for a newbie, like our students, it kind of gets overwhelming. What project should we take? What project can we handle? But if we have a streamlined internship with companies where our students can work under a professional data scientist and gain the experience, that will be something very amazing, for everybody. So do you know of any resources or companies that are open to that idea?
Hmm. Not that I know of. I think, I mean, of course, there are internships available for the summer. I've seen them around on job sites, but I haven't seen of any program. That'd be an interesting idea of like opportunities. It might be a good idea to come up with a matchmaking system between startups and uh, newly minted data scientists. Um, but I don't know. I don't know if such a thing exists,
Yeah,
to be
because I mean,
honest.
the reason why I mentioned was, you being in the field, might have access to resources, or maybe can bring up to your company and, mention
Oh,
something like this, that, we have, graduating students coming out of a respectable training facility who are ready to get their hands dirty with data science. And if they're willing to give our students the opportunity, that would be something fantastic for the company as well as for us.
yeah, yeah. I can bring it up. I mean, as far as I know, at least my division, we're not looking for summer interns this year. But there are definitely summer interns in the company, and I could bring it up and ask them if
That would
if
be
it's
awesome. That
something
would
they're
be
willing to
awesome.
consider. Yeah, yeah,
Yeah, and I mean, if you do come across something, definitely share with us. We would be happy to help your company. Might as well get some long-term employees.
yeah, for sure, for sure.
Uh,
That's always good.
Awesome, awesome. Does anyone has any other questions for Serge?
I just had a quick question, Serge.
Yeah, sure.
Serge, so if someone is, a new data scientist and they're just landed their first job, what do you have any useful tips for them?
If they landed their first job, I'd say the most important thing is talk to the people that work there. You know, even if they give you like some kind of onboarding kind of exercise, like a document that says, okay, these are your first tasks, or this is go to this place and watch these videos and so forth. You think you have everything kind of figured out because you got the document and because you talked to your boss. You know, I I kind of release myself a little bit from that and talk to other people. I'd see if I can get like a buddy assigned, like someone that's been there a long time, that not necessarily my team, that can be introduced me to other people that work in the field to get a sense of what the needs are of the greater department or the company in general. Because that's it, often when you're in the beginning of a company, that's a good time to kind of make your mark, to kind of also push some boundaries a little bit because you're new. So that means that you can perhaps suggest some things that people have already come in the habit that, like these are the way things are, and this is not supposed to change. But maybe you can ruffle some feathers a little bit, and that's a good thing for you and for the company, because I I think it's also a good way to get noticed as well early on. Oh, that's a guy that fixed that problem that we've had forever, you know, or that's the guy that suggested this cool idea that, we're now implementing, and guess what? He's only been in the company for 2 weeks, so it's also a good thing, a way to kind of boost your own confidence. Because when you're there, for the first time, you're feeling a little bit of imposter syndrome, and you're like, oh, do I really belong here? And you feel overwhelmed, but you need a quick win. And these things early on are a lot easier than you think, because you don't have to do too much early on to make your mark.
Okay, awesome. Thank you.
Yeah, to keep on learning and always be positive, like and showcase your work as much as you can. I mean, especially like I understand the struggle as someone that has changed careers of moving into something new. As I told Fatima, I applied to a lot of jobs. I even had one of Chicago's biggest, recruiting agencies. They're specialized in data science recruiting, and they looked at my resume, and they said there was no way I'm going to making six figures, because I had no data science experience. That's what they told me, even though I've worked with data for a long time, and so I kind of felt like very discouraged by that. But it wasn't before long that I was proving them wrong. So I think you can use this as a lesson in the sense that it's you don't listen to other people, keep working on what you're working on, and prove everybody wrong, most importantly yourself. Thank you. Bye.
Thank you, Serg. Have a great night.